Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We from Group 8 for Electronic will present assignment transistor bias circuit. This is our group members. First, Muhammad Akif Faisal bin Nur Aman. Matric number AA212894. Second, Malik Iqra Tanzi bin Malik Ridwan. Matric number AA211463. And myself, Muhammad Raimi bin Roslan, matric number AA212713. So our title group assignment is transistor bias circuit. So what is transistor bias circuit? Transistor bias circuit are circuit used to establish the operating point or bias for a transistor. The circuit ensure that the transistor is correctly biased, so that is operate within its active region, which is necessary for amplification. There are several types of transistor bias circuit, including common base, common collector, and common emitter.
Assalamualaikum and hi, my name is Muhammad Akif Faisal bin Ahmad. My matrix number is AA212894. So today I want to present about my assignment group, assignment transistor bias circuit. So I'm from group 8, so my table is here. I'm from group X, so my VCC is 29, beta is 500, and code 2N3415. So for the question 2, explanation on how you define the IC set value from the datasheet, how I define the IC set value from the datasheet. So here the datasheet, so the code, my code number is 2N3415. So the value of IC set is here, collector emitter saturation, IC set. So the value of IC max is 15 milliampere, and for the VCE max is 0.3.
Okay, so we go to first question. Design a CE amplifier with emitter stabilized bias. So number 5, let VE equal 0.15 VCC multiply with VCC. So from my calculation, this we can see that this VE equal 0.15 VCC. So VCC 29 we get from this table, because we group 8, so our VCC is 29. So this is our value, 4.35 volt. Number 6, RE equal VE IE. So VE from this calculation, 4.35 volt over 50 milliampere. 50 milliampere we got from IC equal IE. This is from datasheet. So we got 18.7 ohm. So number 7, RC equal VC over IC. So VC 14.5 volt over 50 milliampere. So we got so VC we got from this equation. If you can see 0.5 multiply with VCC, our VCC 29, so we got 14.5 volt, and this is our RC. RC equal 290, and IB equal IC over beta. From equation IC equal beta IB. So from this equation we derive, so we got this 50 amp over 500, and we got 100 microampere. So we go through. Okay, this from this we got this equation. So from the equation we derive how to find RB. So RB, if you can see, this is RB, and VCC 29, minus 0.7 VBE. VBE 0.7 because it's constant. Minus 18.7 RE over 100 microampere. So we got this value negative 587 milliampere. That's all from me. Thank you.
For calculation number 2, first question first, select a value for VCC and beta from table 1. So I'm from group 8, so the table from group 8 is VCC 29, beta 500 and code 2N3415 group 8. So the question, the answer is VCC equal to 29, beta equal to 500, code 2N3415. So for the next question is select value for IC set from datasheet. So datasheet from datasheet 2N3415, IC max is equal to 15 milliampere, VCE max 0.3 volts. So select a value of ICQ 1 over 2 IC set. So IC set is 15 milliampere divided by 2. So ICQ equal to 25 milliampere. So for the question 4, select value for VC equal to 0.5 VCC. So VC equal to 0.5 VCC from table 29. So 0.5 multiplied by 29. So the answer is 14.5 volt. So for the question number 5, VE equal to 0.15 VCC. VE equal to 0.15 VCC 29. So multiplied by 29. So the answer is 4.05 volts. So the calculation number 6, calculate RE based on value for VE and IE. So for formula IE, beta plus 1 multiplied by IB. So for IB, we should search from calculate. So first of all, kita search the value of IB. So use formula beta equal to IC equal to IB over IB. So IB equal to IC over beta. So IC 25 milliampere, beta from the table 500. So the answer is 50 microampere. So from the here we know the IB value. So 500 plus 1 multiplied by 50 microampere. So the answer is 25.05 milliampere. So for the VE, the formula is IE RE. So RE equal to VE over IE. So the answer is 103.65 ohm. So for the question 7, calculation RC based on VRC equal to VCC minus VCE minus VE. So VRC equal to VCC minus VCE minus VE. So VCC from the table 29, VCE 0.3 minus VE 4.035. So the answer is 24.35. So for VBC equal to IC multiple by RC. So RC equal to VRC divided by IC. So VRC 24.05 here over IC 25. So the answer is 0.974 ohm. So for the question number 8, calculate R2 for R2 equal to 0.1. So R2 0.1 BRE. So 0.1 BRE beta 500 multiplied by RE value 173.65. So the answer is 8982.5 ohm. So for the calculation number for the question number 9, VB equal to VB plus VE. So VB equal VB plus VE. VB equal to VBE plus VE. VBE 0.7 and plus VE 4.35. So the answer is 5.05 volts. For the question number 10, calculate R1 based on the value of VB and R2. So VB equal to R2 multiple VCC divided by R2 plus R1. R2 plus R1 equal to R2 multiple VCC over VB. So R1 equal to R2 multiple VCC over VB minus R2. So the answer is 41177.40 ohm. So for the question 11, R1 equal to R2 multiple VCC minus VB divided VB. So the answer is same question 10. So the answer is 41177.40 ohm. So for the question 13, calculate IB. So for calculate IB, we should use for formula B equal to IC over IB. So the answer for IB is equal to 15 microampere.
Assalamualaikum warahmatullahi wabarakatuh. My name is Malik Pradhan Zibur Halidan, number matric AA211463. Okay, now I will proceed to the simulation for the calculation number 1. From the calculation number 1, we transfer all the RE, RC and RB to the circuit to get the value that we want. Okay, now I will start the simulation. Okay, to combine all the values, I will pause the simulation and tap here. Okay, from these values, we can see the IB, IC and IE a little bit slightly different with the calculation, which is IB is 45.04 micro 45.04 micro ampere, for IC 20.93 milliampere, and finally for IE is negative 20 for 97 milliampere. Okay, for the second calculation, we transfer all the value that we have calculated into the circuit to find the value of IB, IE and IC. Okay, I will start the calculation and pause it to know the value. Okay, for IB, I get in the simulation is 69.57 microampere. For IC, I get 21.91 milliampere. And finally, for IE, I get from this simulation is negative 21.98 milliampere. As we can see in the simulation, the value for the simulation is slightly different with the value that we get in the calculation above. That's all for me. Thank you.
In conclusion, the transistor bias circuit is an important aspect of transistor circuits that sets the operating point or the quiescent point of the transistor in its active region. This operating point determines the transistor's gain and stability, making it crucial in the proper functioning of transistor circuits. The various bias configurations like the fixed bias, self bias, and voltage divider bias are used to set the operating point. The choice of bias configuration depends on the specific application and its requirements. That's all from us. Thank you.